Hello, Guillaume.
Hello, Mark. Hello, everyone. To everyone who is listening in, thank you for joining. We're happy to have you. Maybe good morning, good afternoon, or evening. And so we have a new conference now from Mark Brouwer. And Mark, it's my pleasure to introduce him. He's the owner and director of Urea Know-how, trying to pronounce it well. Urea Know-how, which is a website, ureaknowhow.com. And we will now listen into his conference, which is the topic we should never forget. It's always good to come back to this topic when we think about work. It's regarding safety incidents, and specifically in the context of high-pressure rotating equipment in urea plants. So without further ado, we will launch Mark's conference, and after that, so you can write in your questions as it rolls, and after that, we will be back on to address your questions. Thank you very much. Talk to you later.
Hello, everybody. Thank you for joining my presentation. Safety incidents with high-pressure rotating equipment in urea plants. My name is Mark Brouwer, and I'm the owner-founder of ureaknowhow.com, an internet platform bringing together the complete urea industry, with the target to improve safety and performance of all urea plants worldwide. I will split up this presentation into 4 sections. Start with a short introduction, then present to you the incidents we have identified with high-pressure rotating equipment in urea plants, discuss with you the prevention and mitigation measures, and finalize with some conclusions. Urea is the most applied nitrogen fertilizer in the world and is also used as a diesel emission fluid to reduce NOx emission from diesel engines. There are about 450 urea plants worldwide producing some 175 million tons of urea yearly. The safety incidents of high-pressure rotating equipment in urea plants are related to several risks. First of all, the high pressures at the discharge site, 150 to 200 bars, while at the suction site there is a relatively low pressure, 1 to 20 bars. A very corrosive medium at the discharge site with the risk of backflow and this corrosive medium is the intermediate product ammonium carbamate. There are crystallization risks and long on-stream periods. Some plants have annual turnarounds every year, but some plants even every 6 years. High pressure rotating equipment is typically running at maximum loads. And there is a release of toxic ammonia or CO2 and overheated steam from turbines in case of a leak. Let's discuss the CO2 compressor in a urea plant. There is no spare position. And typically, the CO2 compressor is operating at a maximum load, determining the urea plant capacity. In the early days, it were reciprocating type of compressors. Later, centrifugal types, inline centrifugal types, and now more and more integrally geared CO2 compressors are applied. Up to 20 megawatts is the power level, and typically the driver is a steam turbine, or it is power driven. Here you see some pictures above of the reciprocating type. On the left side, the inline centrifugal type, and the bottom side, the integrally geared CO2 compressor. Then we have the high pressure ammonia pumps. Here we have one in operation and one spare position. In the early days and still today, you see reciprocating pumps with the benefit of a low power consumption, but also more centrifugal types. Power level is 2.5 megawatts. There is a risk of vibrations, especially with reciprocating types. And also the old designs of reciprocating types have oil seals. And also these pumps operate at high loads. Then we have the high pressure carbamate pumps. Also here, one in operation, one spare. It can be a reciprocating type, or nowadays more and more centrifugal types. Power level is 1 megawatt. And in these high pressure carbamate pumps, there is a risk of vibrations, crystallization, and cavitation. And again, these pumps also operate at high loads. Here you see the pictures on the left bottom side, a modern reciprocating high pressure pump, and on the top, a centrifugal type. The ureaknowhow.com urea incident database, available as open source on our website, contains 135 incidents totally as per January 1st of this year, and 11 incidents are related to the high pressure rotating equipment. Nearly half are related to maintenance, 18% related to the motor or the engine, 18% related to design failures, and 18% are oil related. And we have excluded from this list of 11 incidents the medium hazards related incidents. Here you see the list of incidents, and we have given a number to each incident. The first two figures show the year. So 20 means the year 2020, and 92 the year 1992. And then there is a sequential number, like 20001 is the first incidents uploaded in our incident database, happening in the year 2020. So we see plunger failures of reciprocating pumps. We see a motor explosion, a motor burning, a pressure gauge dismantling incidents, a fire due to an oil leak, acid ingress, a major ammonia leak from a reciprocating pump failure, reverse rotation of the CO2 compressor, and even a gas explosion in a recip pump. I like to elaborate on two incidents which are related to oil. And this is an incident which happened in the year 2009, and is the 5th incident uploaded in our incident database. There was a chemical cleaning of the low pressure steam drum in progress with acetic acid. And nitrogen at 5 bar was being introduced through the bottom via a hose pipe for mixing purpose. Due to multiple uses of nitrogen, a pressure dropped at the utility header, and the acetic acid flowed reversely into the nitrogen utility station due to the static head of the steam vessel, resulting in contamination of the nitrogen utility station with acetic acid. And this nitrogen was also used at the CO2 compressor loop oil system. So acetic acid did ingress into the bearings. And of course, that resulted in a severe damage of the CO2 compressor bearings and seals. Yeah, this incident shows clearly the risks which typically occur during a turnaround, and a proper risk analysis is good practice. Then we have the incidents which happened in 2010, where a fire happened due to an oil leakage in the compressor. Luckily, the firefighters could snuff out the fire within a short time and could prevent damage of the plant. Of course, the production stopped, and there was a technical glitch as a cause. The fire broke out when oil and gas came in contact with the overheated engine through a leakage in a compressor tube. This is an incident which happened more often. And insurance companies are very keen preventing these kind of incidents. So for the lessons learned, we kindly refer to the American Institute of Chemical Engineers paper, Fire Protection and Detection for Critical Rotating Machines, in 2016. What are our proposed prevention and mitigation measures? First of all, companies do not have a memory, and incidents do repeat. And we recommend to make use of the Center of Chemical Process Safety, the CCPS, risk-based process safety management approach. And this approach includes 4 pillars: commit to process safety, understand the hazards and the risk, manage risk, and learn from experience. And we hope that our Urea incident database will contribute to this 4th pillar. Install state-of-the-art leak detection systems. Leaks can occur from flange connections, from valve bodies, from pump and compressor seals, but also general leak detection is important. And we'd like to highlight 2 innovative companies here on this slide: Gexcon, which can simulate leaks in a very accurate way, and Grand Perspective, which can make visible with special camera techniques any leak in your facility. Make use of reliable and experienced vendors, because note that ammonia and CO2 is at supercritical conditions at the discharge site. And ammonium carbamate is very corrosive. Remember that the equipment is typically running continuously for years at maximum or high loads, and that the periods between turnarounds have increased from 1 to 6 years. And we have good experience with MAN from Germany and New GCM, an upcoming innovative company from China. Our 4th recommendation is make use of the proper design, installation, operational and maintenance procedures. And points of attention in Urea plants are vibrations, corrosion risks, the wear and tear and fatigue with reciprocating types of machines, apply risk-based inspections, take care of leakages and fire risks, and oil conditioning is critical. Remember, we are running at long periods at high loads with reactive process media. And of course, there Fluidtech is a recommended company to involve. And that brings me to my conclusions. The ureaknow.com Urea incident database contains already more than 135 serious incidents, of which more than 10 occurred with high-pressure rotating equipment. To minimize or avoid that incidents do repeat, we recommend strongly to make use of the Center for Chemical Process Safety risk-based process safety management approach. Involve reliable and experienced vendors. And also pay proper attention to the right design, installation, operational and maintenance procedures. And involve experienced and knowledgeable Urea experts as owners, engineers in your projects and training programs. Treat safety and reliability as your #1 priority. It will pay back. And that brings me to the end of my presentation. I thank you very much for your attention. And please let me know if you have any questions. Thank you very much. Hi, Guillaume.
Hello. Hello again. Mark, thank you very much for this. I listened with a lot of attention. I think it's first is very key. No one should ever get hurt on the job. And second, there's a lot of learnings. I will listen to this presentation, to the recording again, because I think there's a lot of information there. And we have a first question coming in from Christopher.
Mm-hmm.
So what are some good ways to bring safety insights and requirements from the design phase into operations and maintenance phase?
Yeah, that's a good question. Thank you, Christopher. Of course, during the design phase, it's common to do a hazard and operability analysis. And also, it's good practice to repeat these hazard exercises every couple of years. Although this is a good basic instrument to introduce sufficient safety and reliability measures, experience has shown that it does not typically cover all the risks and possibilities. If you look at our incident database, you will see that there are incidents happening which were not identified in a hazard during startup and shutdown periods of a plant. Then the process is more dynamic, more unclear in which phases it occurs. And we have seen that to solve this shortcoming of a hazard, it's pragmatic good to take into account the incidents, the incidents which happened in your plant, in your earlier phase, or the incidents which happened in the industry. And that is one of the major reasons why we started up introducing Urea incident databases, and also for other processes like ammonia, together with ammonia know-how, because you will see that it's good to take these into the design phase, incidents which typically are not covered in the hazard and which people maybe think it cannot happen, and it still did happen. So I think hazards and incident databases are two good measures to include in your design phase, the safety measures for operation and maintenance.
And if I understand Christopher's question well, it seems to suggest that he has a concern about a handover of safety practices going from the design phase into the production and operations phase. Have you seen this?
Yes, it is, of course. You need good manuals, you need good operating procedures, and that is a big effort also. Good training of your operation and maintenance people. When you have an existing plant, you typically see after 20 years that the people who started up the plant, they start to retire, and new fresh people are coming. And yeah, this is an important item to keep operation and maintenance people well trained and well informed. And yeah, good ways is again a good manual, good SOPs, standard operational procedures, I think, or checklist, training sessions.
Thank you. I have a question. So, what made you start your incidents, your own incidents database? I would expect these incidents should be in each country's industrial safety, industrial incidents database. And so, is it so that you cannot find which is specific Urea compressor related in these databases, or that some information you find missing from these official databases?
Yeah, we have seen that the owners do not like to elaborate too much on incidents which happened in their plant. The licensors are also not very interested to elaborate on incidents which happened in their plant. So nowadays with internet, which is expanding exponentially, it becomes more easy to find information. Our network is also very helpful to find information. And we keep incidents also confidential, so we don't identify the plant or when it is not publicly known, and that also helps to convince members to come up with incidents or nearly misses. If you have an operating company with several plants, it's more easy for them to learn from their earlier near misses and incidents. But if you have a new plant and only one, yeah, then you need to start from scratch, and then an incident database from the industry is very valuable.
Yeah, I used to be in a large oil and gas company and worldwide, so a big noise was made about every incident internally.
Yeah.
But of course,
Yeah,
it was a large enough company that. Yeah.
Right. And the same is happening in the airliner industry, the airplanes. If an incident happens with an airplane, it's all publicly shared. But this is certainly not the case in our industry yet.
To convince someone whose job responsibilities is health and safety, that he can influence his colleagues to try to reduce reliability incidents, because the more you have, the less unplanned work you have to do, the less safety risk you have, don't you?
Yeah, I think the most convincing argument is safety. Start with safety to avoid casualties, injuries. That is very. No company likes to get involved in such a case, and reliability is of course related to a payback or to a reduction of cost or avoiding cost. Avoiding unplanned shutdowns.
I actually saw a slide once that was showing the difference in safety risk between work and unplanned work, and it was very, very large difference. I never managed to get my hands on this slide again. I just saw it on screen. So, Christopher, I did a comment.
Yeah.
So about the detectability of potential hazards, such as fatigue, wear and tear. What does this bring to your mind?
Yeah. Good point again, Christopher. So preventive maintenance, risk-based inspections. In urea plants, you have a big issue with fighting corrosion. First, you need to know what are the failure modes. So training, sharing knowledge, sharing earlier incidents. It's important. And then you have to know where to look at. If you know where to look at, you can do these inspections and look for fatigue, wear and tear, especially for reciprocating pumps. There are several cases, incidents which were related to that. Corrosion plays also a role here. And yeah, it can be hard to detect, that is true. If it is, it can be a unique or a first case in the industry in older plants. On the other hand, I think our industry is 70, 80 years old. And if we share more near misses and incidents, more people will be aware where to look at and how to assure safety and reliability in their own plant.
I think one of the things you said in the presentation is that we see repeat same incidents. That's really sad to hear, because if it's happened once, then everybody else should know about it and avoid. None of us want to be hurt on the job, but it's worth it. So yeah, share to avoid repeats seem to me key. Another thing that struck me, I didn't expect that, is you mentioned 18% of incidents are linked to lubrication, and this is a lubrication conference. Do you have any other specific tips regarding the lubrication side of these machines from the safety angle?
Now, yeah, I think lubrication hazard related with fire, leaks and then fire because of the turbine or some high temperatures close by. That is a well-recognized risk in rotating machines. This other incident was with also a turnaround cleaning exercise with an acid, acetic acid, which could enter into the loop oil system.
Yeah, you had a presentation.
I'll see also
and we
contamination.
Have a new comment from.
Please.
Sorry. Go ahead, Mark.
You can also think about contamination of the fluids with oil, creating issues with oil. And yeah, the longer the on-stream periods become, the period between turnarounds is really increasingly significant, because of course every turnaround is costing a lot of money, and a long shutdown period that will put more emphasis and higher demands on the lubrication performance.
Thank you. And a new question from Christopher: for the use of very high resolution drone cameras for inspection to detect corrosion.
That I have also seen that to detect corrosion under insulation. I think you are referring to, Christopher. And yeah, of course, these new type of techniques, by the way, also in storage tanks, indeed, or crawlers are used inside pipelines, because if you have a pipeline of, let's say, 400, 500 millimeter, the camera can still go in and look at potential corrosion issues. So for sure, that will be techniques which will become more important, and if the costs go down, it will be more easy to do. Also, there's a nice development with robots who can do tours to support operators and maintenance people, go through the plant at regular times, and with several cameras, these robots are sending the visuals to the control room. So that are also nice techniques to think of.
Yeah, exciting new options. Okay, we have about 1 minute left and no more questions. So, Mark, I thank you very much for this essential session, and to everyone in attendance. If you have any more questions regarding this topic, this key topic, then don't hesitate to get in touch with Mark via different channels. You can find his profile in the app. So don't be shy, don't hesitate, and do go ahead and get in touch with Mark. Okay? Again, thank you very much.
Thank you, Guillaume. It was my pleasure. Thank you for the opportunity.
Cheers. Dankjewel.
Bye-bye. Have a nice day.
Bye-bye. You too.